In this video, we're going to use the change of base formula to approximate a logarithm on our calculator. We see here, we're given the problem log base 4 of 25 is equal to log base 10 of 25 divided by log base 10 of 4. Now, our calculator, we can only calculate two types of logs on our calculator. We can calculate log base 10, which is often just written as log, or we could calculate the natural log, which is log base e, but because it's used so often, it's abbreviated as natural log or just ln. When we're asked to calculate any other base, such as in this problem, log base 4, we can't use our calculator. We can't use most calculators. If you have a smartphone, there's probably an app that you could use that will calculate other bases. But if you have a test-approved calculator, like a Texas Instrument calculator, we can't calculate log base 4. So we're given a rule, and the formula is, I'm going to use variables. Log base a of x is equal to log base b of x divided by log base b of a. So just notice here when we're using this, all that really matters is that on the right side, we're using the same base for each one of those logs. Now, let me box that in. You might ask yourself, well, like, why exactly, like, where did that come from? I'll do a quick proof of that. So if we have log base a of x, and we could say that that's equal to some number y. We don't know what it is. Well, if we could rewrite this, let's actually rewrite this for our purposes. We'll say a to the power of y is equal to x. So what I just did, I just rewrote my log statement as an exponential statement. Now, if here we just decided to take the log of both sides, so say we took the log of the right side and we took the log of the left side. I'm just going to rewrite it because it's kind of squished over here. Okay, so we just use the properties of equality to do that. Now, there is a property of logarithms which we haven't quite looked at. We'll take a look at it in the next section. That if we have the log base b of something to a power, we could rewrite that as the power times our log. And now, if I just divide both sides by log base b of a, we see that on the right side I have log base b of x divided by log base b of a. And that is my change of base formula. So now let's just put it in practice, right? We're going to approximate this using a calculator. Now, we've already been asked calculate log base 4 of 25, and it already tells us they've already used the change of base formula for us. If we were given, say we were just given this problem right there, and it said calculate that for us, punch that into a calculator, you would have to recognize that this is not in base 10 or base e, so you can't use the log button on your calculator. You can't use the natural log button on your calculator. But you'd have to rewrite this. And you'd rewrite this, I like to rewrite it using the common log. Log of 25, that's this, the big number there, divided by common log of 4. And you could just remember, it's pretty easy to remember the change of base formula. The base here, this 4, ends up being your denominator in the bottom. And you could just take your calculator, So that's log 25 divided by log of 4. So log of 25. I could do this in one step. I'll do it in two. So 1.3979. So this ends up equal to 1.3979 divided by log 4. Oops, this is not right. Log 4, enter. So that's 0.6021. And then we could just go ahead and calculate that. Or we could have done it all in one step. Log of 25 divided by log of 4. And you get 2.3219. 3219. Okay, so just one more time. If this was the question and they asked us to approximate this log base 4 of 25 on your calculator, you would have to do this work on the right side in blue. And we would get this answer, 2.3219, as our approximation.